All right, we're back. We're looking at 4.6 in Techmath1. Chapter 4, Blue Book. Go to page 160, and we're looking at 51. So 51, these are three types of percent problems. So they're written sort of like in English, and we're going to convert them into a math problem. So what is 50% of 138? What 63% of 837 is what? So when you're converting from English to math, what means X, that's your variable. Is means equals. Percents have to be converted to decimals. Of always means times. And numbers still mean numbers. So we just convert it from English into a math equation. And so now look, how do we solve that? Well, this kind of solves itself, right? 0.50 times 138, or just 0.5 times 138. What is that? Don't they tell us, or we just had to set it up? Well, just translate. Well, now I kind of want to know. So let's bust out the calculator, figure that out. They just wanted a translation. But if we were to solve that, I needed half of 138, and it's late, so I cannot do that in my head right now. 69. So X would equal 69. That would be the answer for that. So 69 is 50% of 138. What's half 138, basically? All right, let's take a look at this. 63% of 837 is what? So this would be, you convert that to a decimal, 0.63. Of always means times. 837 is always means equals. And then what? So just 0.63 times 837. That is 456.21. Okay. All right, so we convert and find. Let's see, is that just still another conversion? So let's look at 32, or I'm sorry, 52. They want find 145% of 925. So if we were doing that, find 145 of, so this find is all like X equals, that's both things in one. Find 1.45 times 925. So that would be the setup for that. All right, and so if we were to actually find that, then it would be 1.45 times 925. 1341.25. All right. Doggone it. There goes the cap. When they converted it from English to math on the side there, if you're looking in your blue book, they didn't convert the decimals. They left the percents as percents instead of making them a decimal. Don't do that. If you're gonna, when in the conversion process, bump that from a percent to a decimal. It's too easy to forget that step otherwise. So I'm not sure what they're playing at there. All right. Okay, so 20 is, let's look at 55. We'll set those up. Again, we're just translating from English to math. So we've got 20 is what percent of 50? So 20 is still 20. Is still equals. What percent is X of is times and 50, except when we solve this, 20 equals 50x, we're going to get a decimal that we're going to have to convert to a percent. So 2/5 is 0.4. And so that's 0.4 is equal to x, but it asks what percent. So then you take that and change it into a percent. Remember, 2 places to the right. So 40%. So 20 is 40% of 50. You can always check your answers back on this too. Just like all equations. We also have 58 marked. Let's look at 58. We got 50% of what is 20? So that would be 0.50 of means times of what is x. What is x? Is equals, and then 20. So look, that translates into that equation, and if I were solving, I would divide by 0.5, and that would be 40. All right. And then they also have 75 is 140% of what? So 75 is 140% of what? 75 is 1.40, if you'd like, times x. So 1.4x equals 75. I would have to divide both sides by 1.4 to solve that equation. And so if I got that, that would be 75 divided by 1.4. 75 divided by 1.4. Ooh, that's really ugly. 53.5714, blah, 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 blah. 53.5714. We'll go out to tenths, hundredths, thousandths, 10,000ths. We went out to 10,000ths place and then stuff. There was still more after it. All right, let's, next page, look at 60. They want me to solve that. So let's solve 60. We got 12% of what is 200. 12% of what is 200. So that's just 0.12 times x equals 200. 0.12x equals 200. And now you solve that equation. Divide by 0.12, divide by 0.12. And so for number 60, that is, I'll round to the nearest whole number. So if we take 200 divided by 0.12, it's 1666.6666 forever. Repeating, but they said to the nearest whole number. So there's our whole number. We look to the tens place only. And that's going to bump it up. So 1667, 1,667 is the answer to the nearest whole number. All right. Lovely. Okay, let's look at 4.7 applied problems. So like rewording it, you read it over, and sometimes it's easier if you kind of write it to look like this. All right, and so let's jump in and do a couple of problems. Let's do 68. Let's jump to 68. All right, so number 68. And this is 4.7 now. So 68 looks like this. We've got 223 kilograms of copper ore used to make, or no, 223 kilograms of copper are used to make 260 kilograms of bronze. What percent of the alloy is copper? Round to the nearest tenth. Okay. So let's see. X. What percent of 260 is what percent of the bronze, so the 260 is copper, right? What percent of the alloy is copper? So what percent of the bronze alloy is copper? So, but instead of bronze, I put the 260, and instead of copper, I put the 223. All right. Ooh, that was kind of a tough one to translate. So what percent is X times 260 is equals 223. And now we divide. And there is another way to look at this, and I'll explain it another way. So you take 223 divided by 223 divided by 260, and you get 0.85769230077. That's what your calculator has, all right? So now, with that in mind, let's read it carefully. It says round to a tenth of a percent. That means you first change it into a percent, then you round. So it's 85.769230077%. Now, tenth of a percent. So there's our tenths place in the percent. That's the number that determines. And so 85.8% is the correct answer. Now, another way to do this, I've had students say, oh, I didn't do it like that at all. I knew copper was the alloy that they use in bronze, so I just took the part over the whole, part over whole, and divided and got 0.857, and then rounded, made it a percent rounded. That's totally fine. If you want to look at it like that instead of mirroring what I did with the homework, you could do it that way too. That's like how you figure out what you got on the test. If there were 260 points on the test and you got 223 of them, 223 over 260, part over the whole, and divide. And so you got an 86%, 85.8%. All right? Let's look at the second part of 68. That was only part one. Let's take a look at part two. That is a sample of polluted lake water contains 87 parts per million of mercury. What percent is mercury? So X percent of water is 87 parts per million. All right. So this is going to go the other way. So this is what percent of the water is mercury. A sample of polluted water is 87 parts per million. So X percent of the water is 87. So we've got, here, I'll put what percent? What percent of the water is the 87 parts per million? So we've got this. We've got X times 1 million, because it's parts per million. So x times 1 million is 87. We divide that by a million on both sides. And so, now some of you might have said, no, I would just write 87 millionths. I would go, 0.00000. Let's see, how many zeros would that be? 1, 2, 3, 4. 1, 2, 3, 4 zeros. And then an 8, 7. Let's see. Tenths, hundredths, thousandths, 10,000s, 100,000s, millions. This is how you would write 87 millionths. They said 87 parts per million, which is another way of saying 87 millionths. And now remember, this is what percent. So we'd have to convert it to a percent. That would move it 2 places to the right. So 0.0087%. So that's how much mercury is in that water. If it tested out to be 87 parts per million, it's 0.0087%, or 87, what is that, tenths, hundredths, thousandths, 10,000s. 87 10,000ths %. Oof, that's a mouthful. See, that sounds like how scientists talk, and then everybody gets confused. Nobody knows what they're talking about. Okay. So let's look at, for 8, ratios and proportions. And I want to jump to 76. So first, the difference between a ratio and a proportion. Ratio, there's a difference first. Let's identify the difference between a ratio and a rate. A ratio means you're looking at the same units. It's going to be like lengths and lengths, or people and people. So if they say, oh, what's the teacher-student ratio? See, they're both people. Rates, it's different units. A rate is like I get paid $30 per hour. So there's different units, money on top and hours on the bottom. And so that's the difference between ratios and rates. What is a proportion? A proportion is just when you take a ratio and set it equal to another ratio. Then it becomes a proportion, all right? And so let's take a look at 76. That's only one problem I want to do on here. So they want to know, is this ratio 8 feet to 6 feet the same as this ratio, 40 feet to 30 feet? And so the way to do that is write them as fractions and then reduce the fractions. If they reduce to be the same fraction, they're identical ratios. 4/3. So the answer is, yeah, those are equal. Equal 4:3. A 4:3 ratio. All right, so both are a 4:3 ratio for part A. Part B, they got 2 inches to 20 pounds. So that's not even a ratio. It's a rate, 2 inches to 20 pounds. Is that the same as 3 inches to 24 pounds? So we'll say 2/20ths. Is that the same as 3/24ths? Well, no. One is 1/10 and one is 1/8. So that's those are not equal rates. Jeez. We're reducing to determine whether each pair of ratios is equal or not. Okay, they're calling it a ratio, but yeah, I don't think that's a ratio. I think that's a rate. I think by definition, by the mathematical definition, ratios have to both be lengths or both be people or both be the same units. I mean, as soon as you throw in different units, it's a rate, but maybe they're saying, well, he's just splitting hairs. But at any rate, they're not equal. At any rate, all right, on that pun, that ends this video. So we'll see you on the next one for 4.9.